Okay, good morning. Thank you all for joining us. My name is Sherry Goodman. I'm the chair of the board of the Council on Strategic Risk, a nonprofit, nonpartisan think and do tank dedicated to addressing core systemic risks to security in the 21st century. Thank you so much for joining us. We're thrilled to have you all today for this important discussion. Today's event will focus on understanding how the biological threat landscape is changing and key ways to improve our capacity to prevent and respond to emerging threats. Advanced capabilities in the life sciences, a changing geopolitical landscape, and the acceleration of emerging infectious diseases due to climate change are just some of the factors that we must consider as we assess and work toward combating current and future biological threats. We hope today's event contributes to a deeper understanding of how we as a community can help to drive activities to build capabilities addressing biological risks. We could not have a better keynote speaker to start that conversation. With his vast experience, expertise, and leadership in understanding biological threat solutions, we are very fortunate to begin this event with a keynote address from Dr. Chris Hassell, who currently serves as Deputy Assistant Secretary for Strategic Preparedness and Response in the U.S. Department of Health and Human Services. Throughout Dr. Hassell's address, I'd like to invite our audience members to submit questions through the Q&A function. We will get to as many as possible after the address. Again, Chris, Deputy Assistant Secretary Hassell, thank you so much for being here, and I'm going to turn the floor right over to you.
Thank you very much, Sherry. And I apologize to everyone. I just recently relocated my office, and I can tell the lighting is not very good. So, and I also don't have your decorating skill. But if you can suffer through the image, so I appreciate the invitation, and I appreciate the flattering words. See if I can live up to that. Just a little bit about my background too is so I've been at HHS for about 3 years. Prior to that, I was at the Department of Defense as the Deputy Assistant Secretary for Chemical and Biological Defense. So I've been involved in this field for over 20 years. Part of that was actually doing real work, doing research at Los Alamos and a couple other venues, working on technical issues related to CBRN issues. So, that's a little bit about my perspective on this. I wanted to talk today about the topic of convergence. It's a term that's used a lot. I would say it may be overused at times. It's one of those buzzwords that becomes kind of trendy. Global, transparency, convergence, these things that we all kind of adopt because everyone's using it, but oftentimes it's not clear what we really mean when we say that. So I want to maybe be a little provocative and push a little bit back on some of this and maybe generate some discussion. In this particular field and for this venue, there's also the term bioconvergence that's used a lot. And again, I think that also can create some confusion, but also I think a misconception. Because sometimes when I think this term convergence is used, it implies that different fields or different disciplines are converging organically. And in many cases, there's actually barriers to things converging, and especially if we're talking about the government and government funding, it's difficult sometimes to get projects funded, to get programs sort of fully supported if you're focusing on these converging areas. In the government, for example, and I'll go back to my time at the Pentagon, Congress gave us an appropriation and authorization to do chemical and biological defense. That did not include cyber, for example. So even though cyber and bio and the convergence of those two issues were talked about a lot, it was really difficult to include cyber issues into our program. Because again, we had deliverables for our base funding and appropriation. So when I tried to reach over into, say, Cyber Command and say, well, why don't we consider doing an exercise together and doing a cyber inject into a bio event, for example, or a bio event into a cyber event? which adversaries could be looking at, even if they themselves did not initiate both sides of that. They could be taking advantage of a softened environment because of that. And we saw that during the COVID. Well, it's still ongoing to some extent, but especially in the deepest part of the crisis, when there were some cyber events and some cyber attacks that took place because we were in, what you consider kind of a weakened condition. So so even though I'm saying that term is problematic, I'm going to talk about convergence for this talk. I maybe first talk about the convergence of the different disciplines, of the different commodity areas, whatever you want to call it, the CBRN. So I know this is a bio-focused event today, but I'll tell you a little bit about my bias on this. Is my background is in development of instrumentation for detection. And so oftentimes when I would go out into the field and meet with, for example, going to meet with some soldiers at an Army installation and talk to them about what tools they had for doing CBRN defense, and especially looking at the detection capabilities they had. One of the challenges that these people have is these different detector technologies were developed by different groups. And so even just looking at something as simple as the human-machine interface, from their biodetection system and their chemical detection system, they were not at all alike. And so we were asking a lot of people who had a tough job as it is to somehow square all that. And then when you add RAD and other issues into it, it was even more challenging. That's just one narrow area. So we tried to initiate some things where there was more crosstalk amongst those development communities just on the human-machine interface to try to make that a little bit easier. If you look at sample collection, sample prep, it just magnified and multiplied the problem even further. So I think there's a great opportunity. And again, this is not, even though these programs sometimes are grouped together, when you get down into the individual development efforts, they tend to divide out into just what I generally will call commodities. So I think there's opportunities there to bring together those communities in new ways. But it's also important because the threat is converging. So when we talk about a bio threat, for example, it's not just a clean list of threat agents anymore. It's challenged by advances in biotechnology. The last several years with the advances in CRISPR and other advanced biotechnology techniques. These aren't just arcane things anymore. These are appearing in the public media and the popular press, talking about these things and what they mean for society. So one of the things that's come out of that is we're seeing how the chem and the bio area are crossing a little bit. And one example of that is there was some work some years ago where an investigator modified a yeast to produce opioids. So is that a bio issue or a chemical issue? And it almost becomes a philosophical argument at times about which is which. I don't care. It's a threat, and we need to collectively work on it. And both disciplines need to come together on the front end, on the modification, or if there's anything we can do to help detect that modification and deal with that, or on the back end with the actual opioid, which would be considered more of a chemical threat. How would we deal with that? So that's just one example. The other side of that is a lot of toxins. They fall into a broad area called natural products chemistry. And that's a very old field. But part of the work in natural products chemistry is developing a chemical synthesis route to those organic compounds. So just as I was talking about the yeast producing the opioid, which is bio going to chem, this is going the other direction, chem producing something that's considered a biological agent. Toxins are kind of just as an aside, are kind of for those that aren't so familiar, they kind of fall a little bit in the middle. As a chemist, I see them as toxins as a chemical, and they need to be dealt with that way. A biologist often will see that as a biological compound because it's biologically derived. Again, it's an interesting academic, well, academic's probably not the right word, but it's an interesting philosophical argument perhaps, but I'm not sure it's very meaningful. It's something everybody has to work on together. So again, it's something that is going to need a little bit of push to get those areas of converging technology, or the converging areas of CBRN to be a little more holistic and working together. Another area of convergence is in just areas of technology itself. I often speak about a study that we commissioned from DoD back in 2018 with the National Academies of Science about looking at the impact of advanced biotechnology and how that was going to impact biodefense. So they issued the report in 2018. You can download it for free. It's called Biodefense in the Age of Synthetic Biology. That's a very good publication. I was really happy with the result of that. One of the key themes they bring out in that is this area of different converging technologies. So, for example, data science to include artificial intelligence, machine learning, deep learning, all the aspects of just what we'll call broadly data science, cyber technology, nanotechnology, automation, all of those things could be converging to exacerbate the threat. So, for example, you could have a delivery system for a biological or chemical agent that is enhanced or facilitated by development of a nanotechnology carrier. So again, that was interesting. One of the other key things that the academies brought out in that report is one of the ways of dealing with those converging technologies is to capture them and use them. So the solution is actually embedded in the threat itself. So if we can utilize AI, data science and other things, nano, automation, all of these, use them to facilitate solutions, that is a key part of dealing with the threat itself. An example of that was during the coronavirus. If you look at the vaccines that were produced, the mRNA vaccines, they relied on a nanolipid particle for coating and for delivery. So that doesn't get maybe emphasized as much as a converging issue, but it did involve different disciplines coming together on that solution. I'll give you one other example. In March of this year, a short piece came out in the journal Nature Machine Intelligence. And this again was picked up in the popular media. What happened was there was a conference in Switzerland that's held every 3 years where they bring together a lot of the CBRN community to talk about challenges and various aspects of it. They asked a pharmaceutical design company if they could do some work and perhaps use their design software, if that could be utilized by an adversary to design a toxin. And this company had never done that before. They'd never even thought about it. They were designing drugs, therapeutics, vaccines, different medical countermeasures using their artificial intelligence technology platform that they had developed. So they kind of turned it on its head, and they used a model using the chemical agent VX to kind of seed the AI engine to run on it. Again, they had never done this before. They seeded it, they ran the program, and in 6 hours, it produced 40,000 compounds that met the criteria that they had set for a toxic agent. And that's only just, toxic agents similar to VX, a nerve agent. I would encourage you to go back and look at that article. It's fairly short, and there's some other follow-on commentaries that came in a couple months later. And I'll put a link in the chat or the QA, or I'll send it to the facilitators here to look that up. It's interesting to see what they did, but it was equally interesting to see their reaction to it. I mean, this wasn't really a scholarly piece as much as just a communication that they put in the journal, but their reaction to what they did, they were surprised that it was this easy to do. and they had never thought about this, and it really gave them pause. Now, everybody's quick to point out, and there's some other follow-on commentaries, and they admit themselves, those 40,000 compounds, not every one of them can actually be synthesized. It's one thing just to run the engine and then to come up with these compounds. It's a far other thing to actually produce them, weaponize them, and disseminate them. So it's not quite as easy as it sounds, but it still shows that it's quite possible to do quite a bit with that. So that's just an example of converging technologies. There's others that we could talk about, again, using nanotechnology as a carrier for a threat agent, for example. So some of the threat agents that may be a little bit more labile or not as stable in the environment, by using a nanotechnology carrier, you could achieve some stability there that would make them more of a threat. So that's an area that needs to be looked at. Again, it needs a little bit of a push to make sure that people are looking at those converging areas. Now, let me turn to converging phenomenon, and Sherry mentioned this in her opening comments, but the area of climate change. So here, looking at maybe more of on a biodefense aspect of a naturally occurring organism. As we see more climate change occurring, especially temperature patterns changing, rainfall patterns changing, it's really throwing things a little bit into turmoil as far as what's happening with the zoonotic crossover. So diseases that may have been in animals that were pretty much geographically limited historically because of climate barriers and limitations, some of those are being completely thrown out because, with migration patterns changing, animals are changing their habitat. So a lot of things are happening there. So what is the impact of that? And that's an area of a lot of concern right now, especially in the zoonotic disease area and the monitoring of that. So we're doing a lot of work with HHS, working with USDA, and especially a lot of world organizations of the WHO to try to look at what is the impact of this. The Pentagon is looking at what is the threat of climate change to national security. Well, actually, it's not just the Pentagon, but the whole national security apparatus in the country. That's going to need a lot of input, and here's where we can look to academia and industry to for their own work to see how that could inform what we're doing. But there's a lot that goes into that, and a sort of a secondary impact of that would be political instability that comes with climate change. What is that doing to our adversaries? Is that changing their motivation to want to maybe take different actions? The economic strains that may accrue from that could have impacts. So there's a lot of knock-on effects of climate change, other than just the natural occurring ones of, say, the zoonotic crossover. So as I talk about the political instability and the economic impact, let me just turn finally to some other areas of converging issues. I'll just call them non-technical issues. For those that maybe come from a DoD background, there's a term we use a lot called .mil PFP. That's a kind of an acronym, but it stands for Doctrine, Operations, Technology, Material, Logistics, a bunch of aspects of anything that goes into dealing with a military situation, and especially if we're talking about responses to different adversary threats. The reason I bring that up is a lot of, like, my former program there dealt with the T that's in .mil PFP, the T of technology. But we had to consider all these other areas too, because the non-material and the non-technical aspects really needed to be considered more fully. And so this goes all the way back to what I was talking about, the human-machine interface, the training, the doctrine, the operations that go along with the technology we developed. But one area here I'll just focus on briefly is an area of behavioral science. So I mentioned the political impact and instability, economic instability. Related to that is just, what are the behavioral science aspects of when we're talking about biodefense and solutions to biodefense threats? again, if we use COVID as our example, we spent a lot of time, you probably read about Operation Warp Speed. We, put a lot of emphasis into the technology and the production, the manufacturing, and then the logistics and the dissemination of the vaccines and therapeutic drugs and the diagnostic systems. And we knew that we had a communication challenge to make sure that we were, letting the public know what we were doing, and why, even though we were compressing the timeline, we were not increasing the risk by doing warp speed. Nevertheless, there was a lot of misinformation, disinformation, malinformation. Any of those terms are being thrown around a lot right now. The term infodemic is also another trending term, not only dealing with those malinformation aspects, but also just the deluge of information. So how is the public supposed to make sense of that? And we should have done a better job earlier on and emphasized that more and put more investment into it and spent more time and attention to it. Now, that's my personal opinion. But what we're starting to do now is look at that. Maybe it's a little bit too late in some ways, but it's never, there's still plenty of people out there that we feel strongly that we still need to communicate with, to clarify the technical information, to clarify or to dispel the misinformation and the erroneous information that exists. And here, we're not necessarily the experts at that. So we're teaming up with colleagues at one example is with the National Science Foundation, the people that are doing the funding of some behavioral science issues, to see if we could collaborate there and kind of come up with some different strategies and some communication campaigns and other things going forward. This is going to be a challenge if, say, we get another pandemic. Again, we're not finished with COVID, so there's plenty of work still to do. But anything that follows on after that, and we've seen challenges with monkeypox, now with polio getting a lot of attention. I know, talked earlier, I think some people here from New York. So there's areas where, this is becoming a bigger concern. And so if we do need to communicate, well, how long lasting was the polio vaccine you might have received as a child, or maybe you didn't receive it because you were, maybe some of y'all are young enough that you were past the stage where this was considered such a threat that you would have been vaccinated. So there's a whole communications strategy that needs to be developed for that. So, working with all of our partners across the government, especially CDC and others, to try to work on this communication strategy. But I think there's an area here where we do need help with the academic community, other experts. There's plenty of people in the commercial communication field that we could partner with. So that'll be an area that is worth exploring. And, I talk about the public health aspect of this, but there's for those that are here from more the DoD side of things, again, we're spending time developing vaccines and therapeutic drugs. Is that warfighter going to be willing to take that? And so that's a challenge. I mean, they can be ordered to do it, but I would proffer that that's not the most ideal way. If we could build confidence so that the hesitancy is not as prevalent as it is now, just in society as a whole, I think that would be important to actually make these different medical countermeasures effective and useful. So again, we're working with others and we're open to ideas and looking forward to getting input for different quarters on this. So let me wrap up here. I kind of bounced around a little bit to different things, and I apologize if I didn't exactly address what the center is really looking for here. But these areas that I feel are particularly important, and we're starting to look at these more. As I've been longer in the government sector, I'm seeing that we need to do more to foster convergence of different aspects of this to try to make sure that it's actually occurring. So there's just not a trite word. I think there's opportunities here, especially for those of y'all that are earlier in your career. If I can tell you, I guess my own personal viewpoint in this, if I could go back, 10, 15 years, it would have been interesting to maybe take a step back from the chem bio rad nuke world and maybe see if I could get a position more in, say, for example, cyber, and really learn what's going on there. That does happen, and we do see people doing that, and it really pays dividends because they gain an experience base there. They know the community, both communities, and so there's been some places where there's some good bridges have been built there. I also just think it's an interesting opportunity. It's a way to differentiate yourself as you pursue your career. So that would be my unsolicited advice there for anyone younger considering this. But I would also say the same thing to companies and especially academics looking at this. I think there's some tremendous opportunities here to cross over some of these fields and really dig into this a little bit deeper. Now, I can imagine the reaction having tried to get funding and grants myself. There's not a lot of requests for proposals out there for that kind of converging technology area, but that's something we're trying to do on our end. But if there's different panels and other venues that any of y'all are sitting on that you could help advise that would be welcome. So I know whether the national academies, there's different federal advisory committees that some people here on this group sit on. So I think there's opportunities for you to inform and help the government to make those decisions, but also I think there's some opportunities there for looking at some academic and industrial opportunities, even if it's using internal funding to get it started. Anyway, I don't want to go too deep down that rabbit hole, but happy to take questions on that. But anyway, so I think there's opportunities here. There's challenges, but I think there's, like I say, there's real opportunities here, and I think they could really pay great dividends. So I think I'll stop there, and I think we'll just open up for questions. And I'll put the link on here for that article I mentioned in Nature earlier.
Fantastic. Dr. Hassell, thank you so much for that insightful discussion. So as a brief introduction, my name is Young-B Lim. I am the Deputy Director at the Nolan Center on CSR, and I will be taking over the moderating duties for the rest of this particular webinar. And I just really wanted to point out that I found your insights on convergence as a mirror that really highlights how siloed a lot of these spaces are at this current moment, and the inability to interoperate across these boundaries is a very significant barrier that we're facing. And that's not just across discipline lines, that's also across industry lines, so between public and private, but also finding those ways to connect people within the government who have that policy experience with the individuals that are innovating both inside and outside to build those future technologies and capabilities and opportunities to make sure that we keep everyone from our warfighters to our citizens safe and more secure as we face biological threats. So really wanted to thank you for those fantastic and insightful comments. And so I wanted to, as the moderator, take the prerogative and ask the first question. We've been getting a stream of questions during your particular fantastic keynote address. And that's that we've been seeing some momentum when it comes to bio. Part of it has been motivated by COVID, but part of it has also been motivated by decades-long work when it comes to people that are talking about building a bio industry within the United States. So we've seen some fantastic progress this past week on the NBBI, the National Biomanufacturing and Biotechnology Initiative from the Biden administration. And so clearly there's some progress being made there, obviously, as well as we increase bio industry and biomanufacturing, that potentially opens up that provides another change in the threat landscape as well, that we'll all have to consider, as well as opportunities. But I'm wondering, from your experience and from your talk, what would you envision would be necessary and the things that would be required to have some sort of a national biodefense or national public health initiative that achieves a lot of, what this NBBI is trying to achieve?
So let me give you one example. that I hold out as, I think, a great example and a successful example is Biomaid. So this is a consortium that was set up by DoD. The hub of it is in the University of Minnesota, but they brought in, I think they're up to 150 different members and collaborators now. So this was set up, it was under what's called the Manufacturing Innovation Institute, MIIs. It's a program under Department of Commerce. But anyway, Biomaid, I think it's biomaid.org. You could look it up and learn more about it. The CEO of Biomaid was at the summit that was at the White House right after the order was signed last week. Doug Friedman, he spoke there. And what they're doing is trying to establish sort of a basis for some of the needed infrastructure and sort of the manufacturing side of trying to foster what's generally kind of loosely called the bioeconomy. There was talk at one time of looking at forming other institutes like that. Again, Biomaid is looking more at the manufacturing side, but if you look at the word that's gone on at, say, Broad Institute on the area of design, how can we continue that? And, is there a role for the government to sponsor it? And with the eye of kicking it off. The whole MII model is based on the government putting in some initial funding, but pretty quickly there's an expectation there will be at least one-to-one matching funding from industry. And the ultimate vision is the government can step away and this thing can kind of proceed on its own. So, the area of manufacturing is taken care of, but the upstream design, some aspects of bioengineering. So there's other places there where I think there's room for establishment of institutes like that. I personally like that because I think it goes beyond just funding individual projects. It's funding much larger, more holistic, sort of foundational technologies and foundational research areas. And within those, there's individual project areas, but I think we need to take a larger view. If we just fund an office somewhere to fund, they may get a lot of money and then fund a lot of small projects. Is that really moving things forward collectively? So personally, I think that's an area I'd like to explore further. And again, Biomaid is a great example.
Fantastic. Thank you so much for your response. So there are a number of questions that I'm going to try to roll into one, and I'm also going to try to do a shout out to Malcolm Dando, who I believe first introduced me to this concept of bio and chem and kind of the blurring in between. So you had mentioned in your talk about kind of this, is something a chemical or something biological, if it's biologically derived and things along those lines. So Malcolm had in the past, I think, talked about bio versus chem as a spectrum. And, where kind of chemical elements are on one side and bio are on the other, but there's this blurred line in between of toxins and prions and, all of these particular kinds of things. So in that idea of that blurred line / convergence area that is kind of amorphous, there are a number of questions that I'm going to try to roll into one, which are asking about how do we balance CBRN convergence? So this idea that all of these spaces are kind of interconnected and working together with ensuring that these technologies have distinct pipelines and purposes, especially as we're working towards building those technical capacities that we need to address not only the individual threats themselves, but the nexus at which these threats converge.
So I think that's at the heart of the real challenge here. When I talk about some of these areas that are converging that need a little bit of help to ensure that they converge, I think CBRN risks deconverging. I guess diverging is the right term. But again, if I go back to the appropriations and the authorities that are granted to some of the government programs, they're together now. That's the one, I guess, downside I've seen over the years of focusing so much on biodefense and bio issues without talking about, chem and rad. And I acknowledge that there's some unique things about bio, so I'm not, that there's a pro and a con to doing that. But, you see more and more work going on focusing on bio. The worst thing I think could happen is that those get divided. And so that maybe there's an Office of Biodefense that's formed that's separate from the CBRN work. So you have the CRN and then the bio on one other side. I think that would be detrimental. It would just exacerbate what's already a challenge as it is. But at the same time, COVID has shown the huge impact that a bio event could have. And, we could spend time talking operationally. You're probably not going to get a chemical event that would ever have anything near that same scale and impact. So I get both sides of the argument, but I just want to make sure that we don't further divide the areas, because I can just tell you that the challenge that I've got when I go and meet with the people on the Hill that authorize our work and fund it is, they're a particular committee or a subcommittee that's focused on one particular area. They want you to deliver on what they are prioritizing, even though they will acknowledge that things like cyber, AI, and other things are important. That's not in their main wheelhouse. And so they're looking at what you're going to perform, given what you've been authorized and funded to do. So there needs to be education up there to show that, there's value in crossing these lanes. Other departments have the same challenge, DHS, DOD, we all have the same issues. Anyway, I'm starting to ramble, but I think that's the heart of the challenge is how do we find the right balance between make sure these things are distinct enough that they get addressed properly versus not making it so distinct that they're done in isolation. I can point out the problem, but we're trying to work on the solution. I'm open to any input on that.
No, I think the fact that you're discussing that this issue is very difficult and requires, a fantastic group of individuals and communities to come together to really talk things through and understand what the path forward is and build the will and motivation to move that forward is very clear. And clearly CSR obviously is very here to help facilitate that. And so at this point, what we're going to do, Dr. Hassell, is we're going to transition from this brief Q&A period. And we really want to thank you for those insights. Also for the audience, we want to let you know that Dr. Hassell will continue to be on this particular webinar. So if you continue to have questions for him, please do not hesitate to put them in the Q&A. But what I'd like to do at this point is transition to the panel portion of today's event. And I am really excited that we are going to have two fantastic panelists and speakers deliver some opening remarks, and then we'll move into an open discussion. So we are really fortunate to have first Dr. Pardis Sabeti, who is a professor at Harvard University at the Broad Institute of Harvard at MIT and the Howard Hughes Medical Institute. She has conducted pioneering research on human and microbial genomics, information theory, infectious disease surveillance, and pathogen early warning systems. Also, just as a fun fact, she is a bassist and lead singer for a group called 1,000 Days. So I almost imagine her as the pipette slinging version of Kim Deal of the Pixies. Just absolutely fantastic. And then second, and definitely not least, of course, we also have joining with us Dr. Akila Kosaraju, who is CEO and president of FairBio, a social venture using AI and deep learning to develop novel classes of antibiotics in partnership with Jim Collins' lab at MIT. And the fun fact about Dr. Kosaraju is she has so many fun facts, you'll just have to reach out and communicate with her down the line to be able to figure out some of what those are. So I want to thank our panelists for joining us today. Throughout the panel discussion, I encourage audience members to submit questions through the Q&A function, and we'll get to as many questions as possible towards the end of the webinar. And so what I'd like to do is kick off the panel with opening remarks and comments from Dr. Sabeti, who will share insights on some of the work she has been doing on biosurveillance and pathogen early warning technologies and systems. So over to you, Dr. Sabeti.
Well, thank you so much. It's an honor to be on this panel with Chris and Akila, and that was terrific opening and keynote. I'm really excited to be here and to start a conversation about where broadly we can be going with all of these new technologies in our fight against deadly infectious diseases. So I was trying to think about where to kind of start the conversation. I'll just give you a little background on myself. I actually started as an MD PhD, and my work was in human evolution. And when I was developing algorithms to mine the human genome, looking for signals of natural selection, the kind that we're seeing every day for SARS-CoV-2, mutations rising in prevalence very, very quickly, but trying to track that back in our history. And one of the things that stuck out to me at that point was that the strongest signals that we were seeing from the human genome scans that were coming from the early Human Genome Project and characterization of variation in humans were mutations that were driving adaptation to infectious disease. And it's basically just a reminder that infectious diseases are probably some of the most impactful threats to humanity. We've been fighting them for decades and centuries and millennia, and throughout all time. And they're so fascinating because they themselves, they are such major impacts on our evolution, but they themselves are evolving in real time. And the kinds of technologies that Chris was talking about, and all it gives us, we're in a different position now where we are now fighting not just with our genomes, but with a lot of our other kinds of technologies that we can bring to bear. And it's a really important moment in our history where for the first time, we actually have the technologies to really have the upper hand against infectious disease. I mean, we had obviously major breakthroughs with the emergence of antibiotics and the discovery of penicillin. There are moments in time and key discoveries, but we're getting to the point where we're really understanding all of the logic and that we can be predictive and anticipatory about what could come and how to stop it in real time. When you think about it, the 1918 Spanish flu circumnavigated the globe and killed an estimated 25 million people in 25 weeks. That level, when we talk about the COVID-19 is obviously the biggest pandemic in most of our lifetimes, but it's not the biggest threat that we have faced or can face going forward. When it comes for our children, when it comes for healthy adults, when it comes for basically each and every one of us, we'll have a different relationship to it. And it's, that in a lot of ways, obviously I have a lot of personal loss during COVID-19, and many of us all know somebody who passed to it. It's an incredible tragedy, but we could be on the precipice of a cataclysm if we don't think we have massive existential threats to us. And the one other thing I often say is this idea that infectious diseases are unique amongst the existential threats to humanity, in that one, I would argue they do cause the greatest amount of death, even in our great wars or modern wars, that they are to be taken very, very seriously for the morbidity, mortality, and economic loss, and just broad human suffering that can come from it, and animal suffering as well, just suffering. But also that the tools that we have to use to stop them are not esoteric, they're not bespoke. They actually, the same thing that will stop a cold going through daycare is the same thing that can stop a pandemic, spreading through an entire population. And so these tools make sense to invest in now because they basically dollar for dollar are already paying for themselves as we are testing. Every seasonal cold season is a stimulation of a real pandemic, and the better we get at stopping those infections, the better we get at stopping something that could be a natural threat or even a man-made threat, as sort of we've talked about a little bit. And then the last kind of piece of that is that the culture matters so much to all of this, that this idea that unlike other existential threats to humanity, where it's hard to explain to somebody why each vote matters or recycling matters, because a pandemic, because infectious diseases have an exponential spread, it is literally true that every single person counts, and one person can launch a pandemic, one person can stop a pandemic. And so there's another kind of twist to it where we really can move the needle and really think about how to work together as a society. There really are no, if you think about it, like there is nothing else that links human beings together more than a deadly virus in our midst, right? It's a common threat to all. And obviously some people, in this case, we saw some people are less susceptible and some people are more susceptible, and that causes people to feel immovable because of that, or non-empathetic, but because pathogens and viruses and other pathogens can move, even though it's not a threat to you today, it can be a threat to you tomorrow. And ultimately, we're actually all in this together. Literally, only an alien invasion would be similar in what it could do for unifying us. And so we should take those opportunities. And we saw the way that these kinds of things can divide societies, but we need to do better. I didn't really talk about the technologies. I'm happy to in the conversation to talk about the technologies. I think, the technologies are there. Genomics, information technology. I think a lot of the stuff Chris was also talking about. I mean, we are in just an extraordinary period in biomedicine and information technology where all of these technologies can be brought to bear, and there's so many different ones. You don't even know which one is going to be the disruptive, transformative technology, because there's so many great potentials out there. I think that is the really fun piece. But obviously, we have to really figure out how to navigate it, how to, as Chris said, get the support that is needed to continue that funding, and to allow this community to work together towards solutions. So those are my comments to start.
Fantastic. Thank you so much, Dr. Sebedi. So what I really took away from that was that, we are all in this together. And I think that one of the things that we also have to keep in mind as we're discussing things related to even COVID, and so, we're talking about kind of COVID responses very much on our minds. Unfortunately, and, as you said, very, very heartfully, death is not, in many ways, death is horrible, but also we're now seeing long COVID cases as people are getting repeated exposures. And that is causing immense amounts of strain on society, immense amounts of strain on our citizens, immense amounts of strains on families as people are having to deal with issues that they had not thought to deal with. So hopefully, as we bring many of these technologies, as well as the pathways for implementation online, and build a robust pipeline for not only just the technological applications, but understanding what to do with the technologies and how they should be used and for what purpose. As that becomes more robust, hopefully we are on the track for building those capacities to address future biological threats. Absolutely. And so I really want to thank you for those comments. And now I would like to move on to Dr. Kosaraju, who's going to share her thoughts on the role that the private sector can have in developing medical countermeasures and other technologies for reducing biological threats. So I open the floor to you, Dr. Kosaraju.
Youngmi, thank you so much. And it was, amazing to hear Chris and Pardee's brilliant insights, and really kind of, a really nice way to start the conversation, because so I run a company called Fair Bio, and we're trying to take novel technologies, like Youngmi said, deep learning, AI, out of a lab at MIT, Jim Collins's lab, that's been at the forefront of synthetic biology and systems biology, for a few decades now. And, I really love the way Chris framed this, that convergence isn't something that happens accidentally. You really have to be intentional about it. And the creation of our organization kind of, highlights that. So this came together through Ted's Audacious project. I know Pardees, you also just, I think, received one as well. And that's, a group of typically philanthropists that come together around major unmet, intractable problems globally. And what I thought was really interesting about it is that it brings together a lot of non-life sciences, kind of high profile people. And I think that may have been accelerated with COVID, this interest in infectious disease and tech, investors and donors getting more engaged in the space. And hopefully that will be, a lasting trend. But what we're intentionally trying to do is pull together computational biologists, bioengineers, life sciences experts around this very particular problem. I think what you see in the biotech side is a lot of companies have maybe one small part of their portfolio focused on infectious disease and biodefense, and then that kind of helps to do proof of concept for a much broader portfolio focused on many other therapeutic areas, and it sort of dilutes the effort around infectious disease. In this case, what we're trying to do is stay laser focused on infectious disease, both by using deep learning to really train the AI on finding novel class of antibiotics, but also we're using a different kind of business model. And I actually kind of wanted to some degree, focus on that. I think coming out of COVID, one of the big surprises for me is I thought that it would really seed really disruptive thinking around how we do the business of infectious disease. Not just the technological capacities and not just, the details of mRNA and things like that, but really is the model working, and so in our case, what we're trying to do is really, many people on this call are probably familiar with the Valley of Death. So that's where, most drugs fail between academia and the handoff to, industry, especially getting to clinical trials. And that Valley of Death is, exponentially deeper in infectious disease. I would say it's, almost bottomless in antibiotics in particular. And so we're trying to bridge that Valley of Death by using philanthropic and grant funding dollars instead of typical VC and commercial funding. And the idea there is that because the return on investment is smaller in antibiotics, maybe you'll get like a 2x return if you're lucky, then try to de-risk these compounds, get them as far as possible, and then try to bring in commercial funding at a later stage. So we're really trying out the model, and we're hoping to share, in journal articles and things like that, whether this will work. And I think that in infectious disease, kind of writ large, I think you see a lot of innovation on the government side in terms of new funding mechanisms with Biodefense, and Chris mentioned some interesting programs. But I think on the private sector side, I really do think there's a call to action here to figure out how to make this more enticing. And I came out of the biodefense space. I worked for a company called SIGA for a long time, and that whole industry really, I would say, came to fruition, after 9/11, and there was the Pandemics and All Hazards Preparedness Act. And there was the BioShield programs that put in billions of dollars to actually buy medical countermeasures once they're developed. And it was so very government driven for a space that, where the government is the only market. And I think there needs to be probably that same level of mobilization around emerging infectious diseases and antibiotics now. So sort of like a PAPA, which is the Pandemic and All Hazards Preparedness Act, like 2.0. But I would actually argue that the private sector should play a bigger role in really kind of thinking through what are the economics that will work for this industry. There was some of that engagement when the biodefense industry was taking off, and I think there needs to be a second round of that now. Last comment I'll make is I think that what we saw with COVID was a lot of the big players, the known players, came to the table, and there were many companies, much smaller, much earlier stage, that had truly, rapid, bespoke technologies that I think could have also really played a bigger role. And I think, any mechanisms to really accelerate that feedback cycle of government to smaller companies with really ambitious technologies, I think would really increase the rapidity of the response.
No, absolutely. Thank you so much for those comments. And so I think there's some clear ties already across the three, across Dr. Hassell's keynote, to the comments that both you and Dr. Sabeti made, Dr. Kosaraju, in terms of looking at potential ways to accelerate and also make these relationships more robust between the public and private sectors, but also understanding that there are significant gaps that do continue to exist. And so trying to find a way to almost experiment and be innovative in this space to try to find out what particular configurations work in what particular ways is a very important lesson for us to continue to build on. So one example obviously was Operation Warp Speed most recently, but what are the other models looking like? How does, say, the BioBot with CDC model look like? How does the Ginkgo with CDC and other entities look like? And, as we continue building on some of these potential, interactions, seeing what works and what doesn't, and refining that process is definitely a part of getting towards that optimal state of building those capacities to address future biological threats. So so we're now in the Q&A session for the entirety of the panel at this point, and I'm going to use my moderator's privilege again to ask the first question. And this is particularly directed to Drs. Hassell and Kosaraju, but I would also love Dr. Sebetti's opinion as well on this. So both of you have had, both Dr. Hassell and Dr. Kosaraju have had experience in government with the Pentagon and in the private sector as well. Dr. Hassell, I believe it was at DuPont. And so I'm kind of wondering, could you share your perspectives, and this is across all three of you, on the interface between government and industry? So what I'm particularly curious about is, there are particular elements that government has incentives towards in addressing CBRN threats or these kind of converging threat spaces. And then there are also obviously certain incentives on the academic and industry side in engaging in these spaces. So I'm kind of wondering if you all, from your experiences, could talk about where these spaces overlap and where there may be potential gaps where there need to be further conversations that need to happen as we try to get some of these engagements going. So maybe we could start with Dr. Hassell, then Dr. Kosaraju, then Dr. Sebetti.
Sure. So I particularly picked up on what Akila said about, the feedback between government and small industry in particular. I think that's very important. A couple of ideas there and things that seem to be working. I'll go back to Biomaid if I haven't beat that one to death too much. I went to their first annual meeting earlier this summer. There was a lot of government people there, since there's a lot of government funding going into this. There's, government as part of the governance of Biomaid, along with industry and academia, since it's, University of Minnesota centered. The interesting thing there was a lot of small companies there that were presenting, and what they were doing. Fascinating broad spectrum of areas where they were utilizing advanced biotechnology, so advanced materials aspects, fuels, as well as pharma and pharma precursors. So there were a lot of small companies that were there that needed help with, like I said, the infrastructure and, lessons learned from one another. So it's great feedback there among the small industry group, so they can all help each other and then reach out to some of the bigger companies and to the government where needed. It was also interesting that Lockheed Martin was there also. Even though they're not, they don't have as specific a program as some of the smaller companies, they do see the future in, in biotechnology. So they were there. There's some other big companies there, but I just happened to be in the discussion from the lead for Lockheed Martin. It was just interesting to hear their viewpoints. So I think, the more we can do to foster those kind of venues to help with that. So that's why I'm advocating some of these other institutes, if we can find a way to design those. Professional societies is another one I have a strong feeling for. I'm a strong advocate of professional societies. So I've been active in the American Chemical Society, American Society for Microbiology, just to name two, that we've engaged with. We've tried to, hold panels and other things there to try to, again, do that feedback that Akila was talking about. And don't mean to not to look at Pardis also. I mean, I remember Pardis and she might not remember, she and I actually met in Andy Weber's office in the Pentagon quite a few years ago during the Ebola outbreak in 2015. So strong advocate of also making sure that we bring academia along there. And I just see a big Venn diagram of all these different pieces, making sure that they're intersecting, doing what we can to foster those intersections. Non-governmental organizations also play a role, CEPI, Gates Foundation, and others. So anyway, I'll stop there.
Fantastic. Thank you, Dr. Hassell. Go ahead, Dr. Kosaraju.
I kind of just want to echo some of the things that Chris said, like these opportunities to have discussions in a more open format and really build some of those relationships is really essential. And I do think that that's happening more. The other thing is, and this is, I just kind of thinking on the spot, but what I noticed at DoD is that the reporting requirements to Congress sort of push leadership and incentives in the direction of later stage technologies. So like, for example, when you see, and I don't maybe want to overly highlight CARB-X, but I think CARB-X has this on their website or in some of their reporting is, how many drugs get into clinical trials or get through a phase 1 or things like that. And I think if there's a way to have a reporting requirement or metric for early stage, and maybe it doesn't need to be as high priority, but is a priority, that shows how many novel platforms have been seeded and things like that. And I think if that's incorporated into what's reported to Congress or whatever other oversight mechanism, then I think that leadership in these organizations will actually feel that it's an essential, not sort of like nice to have, but not core to the mandate and the mission, type of funding and just programmatically being able to move more of these small programs forward. So I think there's something in the incentive structure and the reporting structure that might be able to be improved.
Fantastic, thank you. Dr. Sabeti?
Well, I mean, I think Chris and Akila really described, I think, answered your question. And I can only speak to something kind of as a broader framing, I think in general. So, speaking, just more broadly in how we kind of address these things, building community, supporting different groups, having everyone feel also empowered in the system. One of those kind of sociological terms I really like is organizational justice. But the idea that the more you build a feeling of organizational justice, the more every actor in the system behaves better and works towards something as a goal. And so I think in everything that we do, I think Chris talking about the different kinds of communities we can create is so important. And I think also driving that to feel as if every part of that community understands something. So in organizational justice, like some of the key tenets are things like transparency, meritocracy, a sense of due process. I think that, historically, and I understand why it hasn't happened, but during, a lot of the DoD funding ends up, necessarily having to go to no bid contracts. And a lot of times people don't know who gets them and why. And I think that those kinds of things really drive people nuts, because when they're thinking like, why not? I've seen it where it's like everyone's trying to scramble and we don't know why. Like, I have no problem when I get direct feedback of saying this is what's wrong with your application, but when I don't know what I'm doing or where to go. So it's difficult because it takes a lot of time to stop and describe these things, and people are just trying to go quickly. But I think that the more we build, essentially one of my other kind of things that I've come to say over these things is that basically also viruses and these kinds of pathogens, they exploit and expose the cracks in the trust in our society. And I think that that's true. I just may feel like every time we hit a pandemic, I'm just ready for what's going to happen. The paranoia, the suspicion, the kind of chaos, and that everybody starts attacking, and then basically everybody's on the defensive, and the whole thing kind of falls apart. And the virus is probably if it's sentient in any way, it's thrilled by the kind of things that happen. So I think that there's doing that hard work of creating really, just, transparent, clear ways of supporting this work, and articulating what the needs are and what, and what the challenges are. I think, within that context, those challenges are real. If it's nascent technology, how do we invest in it? And so the more we really just get very articulate about what the needs are, how to support every person in the system, how to let good ideas rise to the top and fund those ones, but not let everybody else feel out in the dark and not explain to, the better we'll be. I think half of the challenge is really creating something that allows each person to do their best work. So as a more broad point.
Can I just make one other comment too? What Akila was saying about the emphasis on the latter stage work and the latter stage advanced development work. That's that's been a real challenge. And, with DARPA, IARPA, now as ARPA-H is getting stood up, that's always been a challenge, is how do we tie that early stage work to the latter stage developments? People want to see results and how those results are impacting them. So that tends to be why things get skewed more towards the final result. And so again, there's a communication and education aspect to show why I would be investing a lot of money in an upfront design effort, much like DARPA funded at the Broad early on. And there's other examples, I'm just pulling that one out. How can we do a better job of communicating the value of that and the sort of the value chain that accrues from that? I think that's an excellent point. I'm excited that Renee Wegerson has been nominated as the director of ARPA-H. She's got a great background, and having spent time in industry recently, I'm sure she's going to bring a real interesting view to the thing. So I'm excited to see what no pressure, especially since she's not on this call, but I think you'll see that she's going to be focused on that too, and a lot of people are going to be looking at ARPA-H. So I think that'll be a self-fulfilling wish that you'll see some of that communication.
No, absolutely. And so I think that one of the things that I wanted to ping on, because all three of you brought it up in some way, shape, or form, is the biological threat landscape itself. So as we're considering how to address future biological threats, obviously we're defining it by how we're looking at what the biological threat landscape looks like. It's a very kind of iterative chicken versus egg kind of conceptualization there. And so on one extreme, in certain ways, the way we're using right now is the select agent lists and just kind of like these very list-based threat assessment, risk assessment based tangibles that limit our opportunities and our kind of foresight in some ways to what could potentially be the things that are emerging. We're just focusing on these particular items. And on the other extreme is we don't necessarily know what's out there, so we have to consider everything. So that's the theme where the threat space is infinite. So I would love maybe Dr. Sabeti, then Dr. Hassell, and then Dr. Kosaraju, if you have any thoughts on ways that we could reach a happy medium there between that extremely structured, rigid, element versus everything is converging and therefore everything is a threat and therefore we have to address everything. But unfortunately, we also live on a planet that is, we don't have infinite resources. And so, considering those things in mind, what are your visions of happy mediums in terms of how we consider those biological threats?
Well, I mean, when I was saying this sort of three things that make pathogens unique amongst existential threats, they all do a lot of things the same, and there are a lot of pieces to it that are the same. This idea, the kind of concept that history doesn't repeat, but it rhymes. Pathogen outbreaks don't repeat, but they rhyme. I mean, I think all the things that you saw during COVID-19, we've seen before. It hasn't been enough data for people to believe it, but people were talking about asymptomatic infection. People were talking about viruses mutating. People were talking about, long disease and all sorts of pathogens, infections before. I think the nice thing about COVID is all of that language has now been kind of codified, and now we actually understand those things. But I think that, I don't know whether or not we have to make a choice, in some ways. I think that most of the pathogens, they work very, very similarly amongst medical symptomatology and medical diagnostics. They're pretty unique in that there's usually a smoking gun, not always. Like in Lyme disease, you can't always find the pathogen, but you usually can. Right? It's the first thing we can do in precision medicine, right? In precision medicine, it's like, okay, what does that mean about your particular symptomatology? But it's like, oh, you've got COVID virus circulating in your blood, you've got COVID. And you can say the same for TB or for kind of any of these diseases. So in my mind, I don't know whether or not we have to make a choice. I think that we should focus on the things that actually cause the greatest morbidity and mortality, because we know that we are in that context, like helping society as a whole. And if we build better healthcare systems, we'll do better in the future. And we can look at a few pathogens, like there's certain ones like Nipah or CCHF that are hot on the list of things that have pandemic potential. And that those are places where we can focus some attention. But honestly, like a lot of the work you're going to do for any pathogen, that's why it's so easy to switch gears every time a new outbreak happens, and why, everyone, like a lot of people in the field can switch over, because what we're learning about one will inform the other. There's a certain kind of logic frame that we're looking at. So I don't know if that answers your question. I think that's more broadly saying, I don't know if we have to choose. There are specific pathogens that, and usually when people ask me, they're like, what do you think is the next big threat? And I was like, mostly things that were threats before. My group has a project where we simulate pathogens via Bluetooth. We've been doing it since 2015. We've had a program where we're teaching middle schoolers about pandemics, and we actually have an app that spreads a virtual virus via Bluetooth. And middle schoolers, high schoolers, now college students are doing like full simulations of outbreaks on their campus with hundreds of people participating. And back in 2019, well before COVID ever hit, we were spreading an SARS-CoV-2 like SARS-CoV-like viruses, original SARS-like virus that spread asymptomatically. We actually already knew that was a threat. Why? Because SARS was a big threat, and what could make it worse? Asymptomatic infections, which we had seen before in other cases. And so, honestly, like if you wanted to say, what do you think is the next threat? It's something that was a threat before. Flu is a big one because it did a good job before. It went away for a little while, but it can come back around again. Lassa virus looks like it's a huge pressure on human populations. I would worry about Lassa virus. Ebola has had outbreaks, a couple changes, and the thing picks up a few new properties and it's off to the races. So I think it's while there's always virus X that may come out of nowhere and surprise us, every outbreak that we've had in the last decade is something we've seen for Zika in 1947 was discovered, probably been around a lot longer. Ebola, discovered in 1976, probably been around a lot longer. So, and SARS-CoV-2 since discovered in 2002, but fundamentally every outbreak we've seen before, we could have been ready for. So if you want to look to see what are the threats we should be worried about, it's just look at your history. And that's probably what's going to be the most likely thing that's going to come out again with just one more trick in its sleeve.
Fantastic. Dr. Hassell?
I would agree with everything that was just stated. That's all well said. Just maybe talking about an approach, one approach to dealing with this issue, because I'm very strongly in the camp that these lists are growing more and more anachronistic. There's a reason why they're there, and they're based upon history and previous CBRN programs, or different disease threats that we've faced on the public health side. So there's a reason why they exist, and they're easy to use for prioritization and for building programs, but they don't really get at what the emerging threat really is. And again, I go back to that 2018 study. Even though people talked about this a long time, I use that study because it's something I can show as a consensus among subject matter experts across the field, showing basically one of their points is that the list-based system is going more and more problematic. That's kind of why I go back to that study on that I mentioned in Nature with the AI using for the chem. We've been talking about that in Bio for a long time, but that showed how the same issue applies to the chemical threat. So one way we're trying to get at this is, because if we're going to go toward this completely, agnostic approach to things, we're still going to be stuck with a list for a while. And there's going to have to be a trade-off because we don't have infinite funding to sort of pursue both at the same time. But one approach is, it's termed, threat agnostic countermeasures. That we're at risk of that becoming another trendy thing that really, there's not complete agreement on what it means and what the approach is. But it would be, rather than, one aspect of it is, rather than dealing with, a medical countermeasure to deal with the pathogen itself, deal with the symptomology and the host response. So we have one program here dealing with, what is the ideal medical countermeasure, or can we develop a better countermeasure for acute respiratory distress syndrome? Things like SARS-CoV-2 and other pathogens, that bug triggers ARDS in many people. So, treating it that way, that's one way of really dealing with something that really doesn't care what the pathogen is, it deals with what the impact is. That's not going to be the ideal solution for everything, but it's something that I think needs to happen. The same thing on diagnostics. That's a real challenge, and as we've seen with several events in the recent history, diagnostics is an issue. So, is sequencing and some other methodologies, is there more that we can do there to get after that threat? And so hopefully we'll hear more about that, and you'll see more about this whole threat agnostic approach.
Yeah, I mean, I agree with everything that Pardees and Chris said. And one thing I would add is I think that there's probably on the industry side, I think two areas that probably need more incentivization. One is prioritization. So keeping teams focused on the priority of infectious disease, especially once they have a broader platform. And I think government does have a role to play there. And there are some novel mechanisms being thought through, like the CEPI program, where you develop a vaccine, I think, until maybe phase 2A, and then you kind of leave it on the shelf and you get paid to have developed it to that point, so that if there were to be some kind of pandemic, my understanding is then you can ramp up, at that point. But what that at least does is keeps the team at a company focused on one particular threat area, and then you have some kind of commercial model, and then you can scale later. The second piece is on the platform side itself. There is a business model there. You see it with mRNA, and other like AI that we're working on. Lots of success in that space, and I think like if you can combine really thinking through at a systems level how to keep teams prioritizing this space and then also pivoting their platforms when necessary. I think those two things go hand in hand. I don't have like an immediate idea necessarily around it, but I do think that's where some of the innovation thinking around novel models comes in, because I think what you find is that a lot of times, hopefully like companies like Moderna will stay in infectious disease, but now that it's been such a huge success, the market incentives can kind of pull companies like that in other directions. So how do you keep the capability, the team's capability really focused on this space? And I think that's where you need some different business models, maybe parking drugs at phase 2, or, getting through the lesser expensive piece from the development perspective and having a near-term incentive for that before you get into hundreds of millions of dollars in trials and things like that. So I do think there needs to be more thinking around how to keep companies excited to prioritize.
Absolutely. And I think this conversation, it can definitely be a catalyst towards thinking about those innovations and those ways that we can work towards these things that all three of you have been talking about. And so I wanted to also ask a question from a colleague of mine, Matt Walsh, from Hopkins. If we could maybe have Dr. Kosaraju and Dr. Sebedi and Dr. Hassell answer. This has some very interesting implications in terms of not only bioeconomy related things, but also some of the kind of public-private partnership elements, as well as cybersecurity components. What is the future of software as a service in the life sciences, and more specifically in life science engineering? And how does this future relate to security risks?
I'll speak to it at a very superficial level because, I have more of a life sciences background, but my understanding is software services is a trickier model on a smaller scale because you don't have sort of the blockbuster potential of, say, developing a drug. So for smaller companies that are really trying to, have that be the core of their business model, it requires early partnerships and a truly differentiated technology, the attention of the government to validate. And again, I think that goes back to what we were talking about earlier on, is what is the sort of conversational tool that really enables government to hear about these types of technologies very early. Because, I think in the life sciences, you could argue that outside of infectious disease and some areas of unmet need where the market model is really tricky, that the pharmaceutical incentive structure is sufficient that you don't need that much more government push and pull. Whereas in, software services, if it's really tailored towards some kind of infectious disease or government need, you probably do need to figure out some new models, because the profit margin per sale is trickier, and it requires, tremendous scale. So that's just sort of my slight outsider's perspective on that, is that this is probably the next big wave of challenges as far as public-private partnerships.
Great, thank you. Dr. Sabeti?
Yeah, I mean, I think that, just more broadly, I think that it is, I think Akil's right that it's the next big wave, and that there's a lot of things to be worked out. I think one of the big things from my standpoint is from being in the genomic space, constantly thinking about data interoperability and kind of creating that ecosystem. Because I think what I've noticed is that every technologist that's developing a new technology then has their app that goes with their piece of technology and only theirs. And they're trying to keep you looking at their data, but everywhere in medicine, but nowhere more than in infectious disease does everyone else's data matters to your data, right? That because of the communicable nature of infectious diseases, what's happening, like you don't want somebody to go invisible because they're using a different diagnostic or in a different clinic. You actually need all of that data to be really interoperable and interconnected. So it's sort of trying to think about how do you, if you think about it, email did it well, where everybody has different email clients, but all of those things interact and they all end up in the same place, and people can get the data that they want from others. So everyone can have their, diagnostic technology they use or their app of preference, but all of that information needs to somehow be coherent and in one place. So I think if we do that and we do that well, there's a place for government to step in to pay for that, because at the end of the day, that's going to stop pandemics, and that's going to stop, support contact tracing efforts and all of these kind of different pieces. It's going to reduce good data systems are going to reduce costs across the board. If you also think about how wasteful our diagnostic testing was in COVID-19, it's an abomination. I wrote a number of pieces about it. I did a modeling study that showed just how badly we were using our testing, where we were testing healthy people again and again, and not going out and finding out who was infected and who to actually test. And even with a little bit of analytical technology to bear, we could reduce costs. So that's been a passion of mine, of really trying to figure out how to use our resources wisely by using good information technology to do so. And one of our papers is about it's called the case for altruism in diagnostic testing. We also show that if you give away your tests, you'll actually have less outbreaks than if you use it on yourself over and over again. There's a lot we can do here. And I think that, to me, I'm very excited because I think information technology is the future. That's why my group personally has invested a lot in building architecture for really good contact tracing and data usage and piloting that, because I'm passionate about it. And I think that it only works if everyone actually works coherently. It's not a winner take all model. It's allow different new advances to come to bear and figure out how to allow that to be interoperable and shared across lots of platforms.
Fantastic. Dr. Hassell.
Yeah, I don't think I have a lot to add. I would just maybe key off of what Akila said about looking at some of the different models that already exist. One thing I see in this field oftentimes is oftentimes we'll get a lot of people with a bio background talking about this, and if we could bring people firmly from the data science aspect into it, and especially if we're talking about software and different aspects of that, making sure they're part of that conversation. I use an example that there were a lot of people talking about the threat that cyber posed to different bio things, even genomics and others. But I started noticing that most people talking about this were people who came from a bio background. There was a meeting I went to a few years ago where the organizers went out of their way to get cyber people into the conversation, and that was illuminating because they really brought in their expertise and their experience. I think this field has done a great job of this. If you look at what's a euphemism for the whole synthetic biology area. Another area, another euphemism for it is engineering biology. That's just exactly it, bringing people with that data background, the engineering background, applying that to bio and bioprocesses. That's what resulted in a lot of the advances. But you needed to bring people with that background into it. So, and they may already have the solution. We're just not talking to the right people. So again, the models may be there. We just need to talk to the right people and see where they are.
Absolutely. And I think communication clearly is the key here, whether it's across technologies and making sure that they can interface with each other, whether it's across communities to make sure that everyone's on the same page, or whether it's across society to make sure that we're all working towards that same end of making the world safer and more secure. And so I know that we've discussed a fair amount of issues concerning some gaps, and clearly those are things that we're working on. But I want to make sure, as a part of this panel, that we end on a, positive note, because we are building these capacities, and the individuals that have joined us, Dr. Hassell, Dr. Kosaraju, Dr. Sabeti, are all on the forefront of making these things happen. So just to end really quickly, maybe a 30-second final note from each of you, and we can start with Dr. Hassell, then Dr. Kosaraju, and Dr. Sabeti, on what you're most excited for on the future capacities that we're building at this point.
This will sound trite, but I mean, the more we talk about these gaps, they really do identify opportunities. So you've heard examples here from both Akila and Pardis about some of the work that they've done, particularly skilled at bridging some of these areas. So, talking about the app and some of these other things, bringing in some of the non-classical solutions. And I'm excited about what's possible. And as we, if you saw what engineering biology was able to bring to things by bringing some of these different disciplines together, I think there's just, orders of magnitude more opportunities there by bringing in even more disciplines and getting people excited about, doing these collaborative efforts.
Fantastic. Dr. Kosaraju.
Yeah, I mean, to dovetail on what Chris said, I think like with all these challenges come opportunities, and, this framework of convergence, I just love it. And I think there's clearly a need for convergence, and you're seeing it. I would say, I would argue in the last few years, and maybe partially accelerated by COVID, the convergence of these different fields has been astronomical. And I think it's really exciting and incentivized, amongst the venture capital space and government and, all the various stakeholders. So I feel like the energy is really behind it to do more and more of this. And you're also starting to see proof of concept, like some real success stories, like the mRNA and AI technologies that really are actually coming to fruition with drugs on the market. And I think that the second thing I'm most excited about is I think, going through this really devastating pandemic, the entire world, was interacting with it. And, sadly, but then on the positive, that's also an entirely new generation that is, and I see it often in conversations with, college age and graduate students, a focus on this space that I never saw before. And wanting to bring, fresh perspectives and technologies to it. So I really do think that there's going to be a heyday of talent, flooding into the space, like with climate. I think like Pardis said, this is an existential threat, and I think people are finally starting to live that and want to, really help out.
Fantastic. And the last word goes to Dr. Sabeti.
Well, that's hard to follow, because I think that is those are really great words. But both sets of words, it is a very exciting time. I think I'll just add that I also, with all the transformative technologies, all the opportunities, the youth coming into it, all of that, I completely agree. But also strong leadership, with Renee at ARPA-H and Chris at the helm, like I'm actually very grateful and excited for strong leadership here. I think this is so important, to have individuals with that kind of track record, but also just forthright and sort of thoughtfulness is so important. I mean, basically the whole system works or doesn't work based on the leadership. And I'm grateful for this moment. And I really do think it is the opportunity to take advantage and to move forward in a way that we never have before.
Fantastic. Thank you so much. And so with that, we've arrived at the end of this particular webinar. I would like to extend a personal thank you on behalf of CSR to Dr. Hassell for his keynote, as well as Drs. Kosaraju and Dr. Sabeti for their remarks, and also for the fantastic conversation that we've had. As you all noted, these conversations need to be happening, and in some ways CSR is working on facilitating these conversations. Clearly we have here government, academia, and industry all in a microcosm together having these conversations, and we're looking forward to facilitating many more. So for anyone in the audience, if you're interested, please follow us on the CSR Twitter. It's CSR Risks. And also we have a YouTube page on which this particular recording will go live. And so that you can subscribe to our YouTube channel as well. Yes, I'm doing the share, like, and subscribe type things that some people do. And I, once again, heartfelt appreciation to all of our speakers and all of their insights, and also a heartfelt appreciation to all of the audience as well for attending and being a part of this conversation. I hope everyone stays well, and please look forward to more future events from CSR as we continue on and continue to work on addressing biological threats. Thank you again, and have a great day.
Thanks.